Alright, it's 5 o'clock. It's a little more bearable out here. Um, this case was pretty crappy. And that's what I've been doing, cleaning it off with the single-edge razor blade, which is what I use. I don't have any steel wool. I'm going to sand it and paint it. The problem is going to be, it's got a nice handle on it. The problem is going to be in here. Let me show you, get you on macro. There's little C-clips, very, very, very tiny, holding the handle in. Right there. I could probably get them out, but whether I get them in again, I don't know. But I can't paint this with this handle on here, because no matter what position I put this, I'm going to have an area where it don't get painted, and it's going to probably rub off onto the handle. I really need to paint this because it's got a little corrosion in it. This may not be the pot metal I thought it was. Maybe it's aluminum. I don't know. But anyways, I want to take you inside the shop and show you what I've done. I'm very pleased with this, the way this meter's come out. Let's go in the shop. I've been working on a meter for a couple hours now in the shop, off camera. It's a lot easier for me to work on things, soldering and trying to calibrate it and everything without having a camera on. I can really keep my mind on what I'm doing. So let me show you what I've done in the shop. Of course, I got the AC on. So let me get you onto macro here so you can see what I had to do here. Now, off camera, I adjusted all the ranges, including the half volt scale here. This is the adjustment for the half volt scale. And the only thing I gotta do is I gotta get a D cell. I don't have one. And originally it was soldered in, as you saw in the first video, which is already up on YouTube now, of the flea market finds for Sunday. I have to replace that battery. What I had done here is a 10 microfarad electrolytic right here. Which I replaced. Check, this is a diode here. It looks like a transistor, but that's a diode. It checks okay. The only thing that does not work is this pilot light. I'm getting about 114 volts on here. I don't know why 114, but it might be because of the resistor, because I got 117 going into the meter. So I don't have a schematic of this, but this could be the resistor for the neon bulb. If the neon bulb is defective, I'm not going to be able to replace it because I'm not taking this meter apart. Now, I ran all the ranges on this, and there's some variations, but for the most part it's pretty good. This control here was completely locked up, and what I had done is it was very difficult to get into the back and get my deoxit in there, so I kind of had to spray a little extra in there to eventually get it in there. I also used penetrating oil. When you first saw the video, the last video I just put up before this one, to try to free it, and it didn't work. So what I had done is these knobs come off. It was a little difficult. They just pull off, and very gently with my needle nose, very gently, I didn't press too hard on it, and freed the control. Now the control works fine. The zero adjustment works perfectly. The only scale that's not working is the ohms. I got no control on the ohm scale at all. The needle goes all the way over, and this control does nothing, but I think it's because the battery has to be inserted first. So here I am handling this thing, and it's still on. Yeah, see, here's the zero adjustment. Works perfectly. See? Now if I put it on ohms, okay, normally this control here, which says ohms, would have some effect, but it does nothing. But I think it's due to the battery. I'm hoping that's why it's not responding. I did not have to calibrate the AC. It was right on 118.5 volts. It matched my digital meter here and the meter on the Variac. So I did not have to adjust that. On the back, as I said, I don't have a book on this, by the way. ACZ. I'm not sure what the Z is, like I say. The minus DC, the plus DC has been adjusted. The AC did not have to be adjusted. Now, as I had mentioned, it's easier for me to do these things off camera because I can make a mistake very easily trying to record and do this. So you would probably have preferred to see how I made the calibration. So I'll explain it to you. It's not very difficult to do. What you normally do, and the way I do it anyways, is you set your digital meter to DC, of course. In this case, I use this power supply, which is my favorite because it's 5.5 half amps capacity. Excellent voltage regulation. Put my DC meter on clip leads. Put this meter in parallel with it. Set this to 5 volts. Make sure this reads exactly 5 volts. Before applying the plus terminal right here to the power supply, zero the meter out because you're going to get variations. Not very much though. She's pretty much on. There's a little bit on the low range you have to reset zero, and that's why they have a zero adjust. Works very well. It's very touchy on the low end. So you set that. Once you get that right on zero, and I don't have my face right up on it, so I can't quite tell where I'm at. Once you have that set on zero, then you put your clip lead. In this case, we're doing DC, so the probe is set to DC. You put your clip lead on here, and you see if the meter jives with this. If it doesn't, those adjustments in the back, the plus DC and the negative DC, and the plus and the minus DC, depending on the range you're at. If you're on plus DC and this is off, then you adjust the plus DC. When you're on the minus DC, as you see, I just went to the minus. I got to reset the zero. You guys out there know how to run these things, I'm sure. But this is for somebody that may not be too familiar with them. I'm quite familiar with this. I've had a newer version. But actually, I like this one better because it only uses one D cell. It generates the voltage to your power transformer here and your rectifier and your filter capacitor right there, which is a 10 microfarad. Happens to be a 350 volt one instead of a 200 volt one, but not a problem. I didn't even bother testing it, I just changed it. So each range has to be calibrated, but generally speaking, when you are doing your calibration on your plus DC, for instance, once you do one range, it should be good for all the ranges on the plus DC except the half volt range. Get you on macro here. Down here, when you're down here on the half volt range, first of all you bring your pointer down to 0. Once you get that down to 0, the meter, this power supply is off right now. I set my power supply to 0.5 volts or 1/2 volt. Being that that has an analog meter on it, it's very hard to see a 1/2 volt, so I set it up here to 0.500 volts, 1/2 volt. And then if this don't jive with the digital meter, this adjustment, I think I'm still on macro, this adjustment right here that says 0.5 volts DC, 1/2 volt, that's where you have to make your adjustment. That is the only adjustment you make for that range. You do not use these controls. These controls are for the ranges above 1/2 volt. In other words, 1.5 volts on up. And we have to reset this back. Little touchy at the angle I'm doing it here. Okay, so basically it's not hard to calibrate a meter. There was some discrepancy, like on the 15 volt range, for instance, when I put in 5 volts, it read a little off. When I was on the 5 volt range full scale, it was pretty much on. So there is a slight variation, but only a fraction of a volt. So the only thing now left that I have to do on this meter is to see if the ohms range works. For all I know, it may not work at all. And I won't know that until I put a battery in here, and I don't have... Actually, what would go good in here would be a battery holder instead of soldering it in like they got here. But the good thing about soldering in a battery, you saw the corrosion that was on this. If that was a battery holder, it would have been pretty corroded and you might have to throw it away. Here, the worst that'll happen is the ends of the wire will get corroded off. That wasn't the case here. You can see that these wires are pretty good. So soldering on a D-cell is, I've done it many times years ago, especially when I made those noisemakers and everything. So we can do that. I just got to get a D-cell. A C might fit in there, but I don't have a C-cell. I might have a D-cell in the house. I have a flashlight out here, but I don't want to take the D-cells out of it. So I'll be doing that off camera. The only thing that, like I say, that's not working is this NE2 bulb here. I'm getting the voltage at these leads here, so I would imagine the NE2 bulb is bad. It's unusual because neon bulbs usually last a very long time. So, as I said, I'm getting about 114 volts on these leads, measuring it right here. AC. So, because a neon bulb will work on AC or DC. The firing voltage for an NE2, if I recall, is about 90 volts. I could be wrong. It could be 60. I used to work with neon bulbs all the time years ago when I was just a young goat. The sides, I cleaned and cleaned and cleaned, and it looks a little better. But, you know, I might just paint that. But I gotta do that cabinet and get it done better. I did not go to the trouble of taking the tubes out and testing them. They're a little hard to get in there. What I did here on the cord, the strain relief, I had one hell of a time getting it out. The cord over here was good. It was just snipped off at this point. So I finally got it out, and the wires, like I say, were very good, and there was about 4 or 5 inches of wire there. So what I had done is I have another cord, a thin, non-polarized cord, similar to what was usually on these things. And I brought it through here with the wire about that long, and I put the wires together and used a thin piece of heat shrink, shrunk that down, and I had another larger piece that went over it, so it was doubly insulated, and just tucked them underneath this metal bracket here. I was going to use wire nuts, but I figured that would work out better. I got this thing unplugged, by the way. So the only thing I got to do here, of course, is to put a clip lead on the ground wire, which is permanently attached in here. And as I told you, this isn't too bad, but I think I'm going to paint that anyways to match the rest of it. So that's the story there. Well, the meter is not sitting on 0. You know, I never even noticed that. I've been concentrating on a electronic, you know, zero adjustment. There's no set screw. There's no screw in there. I took a magnifying glass and a light. There just seems to be a plug in there. I mean, the screwdriver goes in the hole, but nothing happens. So I'm gonna have to put this plug back in. That plug is supposed to be there for the adjustment, but there is no adjustment on this, I guess. For whatever reasons, we're not going to screw around with it. We don't need another broken meter here. Okay, what I got here is a good 1.5 volt AA for now. I soldered it in. Got the polarity correct here. So as a test, we're going to check the ohm scale now. So I got to put this back on here, and I just don't know why that don't adjust. All right, hang on a minute. We'll get this thing turned on. Okay, I just turned it on, so it's got to stabilize, just like any other VTVM. They got to stabilize. So I don't know why, but I look in there and it has like a silver thing like this here, only a lot smaller on the inside. So it doesn't appear to be an adjustment there. Why they would have a plug to take out for that, I don't know. I would imagine to compensate with this. Should be. Okay, so compensate here. All right, we're going to put it on ohms now. Well, that's a lot better, and the control works. Okay, this control did not work before, as I showed you. Now, this lead here, I just got it going around the meter here so that it doesn't keep dropping on the floor. I need a clip lead on the end of it. I'll do that later. So we're going to put this lead on here and zero this out and take the clip off just like any other ohm meter. Zero that with the clip on, and we're pretty close. So let's go down to the lowest ohm range here, which is R times 1, of course. So we got to reset this, and we'll grab a resistor. I'm not going to go through the whole procedure of all the ranges to check it. Let's take that off a minute here. Oh, wait a minute now. Yeah. Why ain't that? Alright, I must be doing something wrong here. What the heck did I do here? That's the ground. Yeah, well now I'm on ohms. Alright, something went wrong here. Okay, I guess I lost my R. The R times 1 range is not working, I guess. Because I've got the lead shorted to 0 ohms. But it don't make any difference when I take it off. But it goes to infinity now. And when I touch it on there, goes to 0. Well, it's got to be reset to the 0 adjustment. But R times 1 is automatically going to 0 ohms. That is R times 1. Yeah. Oh, wait a minute here. Wait a minute. No, that's my mistake. I'm down on the 5 volt. This is R times 1. All right. This here, the lowest one down here, is only the half volt DC range. The ohm meter does not. That position is not R times 1. The second position is. Okay, so that's working good. Alright. So that's my mistake. Bad eyesight as always. Can't see anything. Alright, now we gotta go set this to infinity, and we go back. Touch that up just a little bit. Okay, now I'll go get a resistor. Here is a 100 ohm 5% resistor. And to me that looks like it's right on 100. Here is a 1 ohm resistor. Can't beat that, huh? There's your 1 ohm right there. I think this is 5%. This one was very close because I use this as a reference on a lot of my meters. And here is a 1% 1 ohm resistor. So let's get that on there. Just about right on. I got a 1 meg 1%er. Alright, we're reading on a very, we need to be reading down here, so we got to go up 1 range. Okay, we're on R times 100,000 now, but we're going to zero out the meter, and I got to put the camera down to do this. 1 meg. Now if I bring it up to R times 1 meg, I should read my 1 meg right here. Okay, there it is. Now I didn't even zero this, so I really should check and see if that's zeroed. Yeah, that's zeroed right on. So there's 1 meg right there. Now, this is what I like. This meter here has a range of R times 1 meg. That enables me to read much higher resistances than the Simpson 260. Its range only goes up to R times 10,000, which is right here. And trying to read a 1 meg, you're up here. Okay, you can still read it, but if you want to read a 10 meg, it's going to be virtually impossible. So let's read a 10 meg on this thing. 10 meg, this is 1 now. I'm going to leave it all the way up. 10 meg should be right here. I'm sure it will be. I'll go get one. Okay, now this is very, very sensitive. See? Just touching that. So whenever you're reading high resistances, keep your fingers off the terminals. Alright, the ultimate test. 100 megohm. This is a very high precision resistor. (100 megohms). Needless to say, very sensitive. Now if you was to put your fingers across here, now you're down to 40 megohms, 45 megohms. Okay? So that's what I'm saying about reading high resistances, not touching anything. Okay, so that's it on this. I may or may not make a video on painting this. It's not that important. But I did want to show you this and this other power supply here that I got today. I got to run it through some more of its paces. I don't think I really need to do anything with this other than to find a place on the shelf for it. I'll find a place. It's in like brand new condition. I'm very, very pleased with that purchase. Okay, so that concludes the video today of the RCA Senior Voltohmist. Alright, so we're going to close everything down now. Unfortunately, I cannot adjust the zero adjust, so when I turn this off, this needle's going to go off a little bit to the left. A mechanical adjustment, I cannot make it. I'm not going to risk getting in there and damaging it. We can compensate for it with this control here, and that's good enough. Now, it may be better if I lay it on its back. As a matter of fact, it definitely is. So, laying it on its back, which is not the way I want to run this, the needle sits right on zero. So it's a mechanical adjustment. I got to get a decel. This is only temporary. Thanks for watching.